Hello everyone, welcome to Zero Labs. Today is Sunday, June 21st, 2015. I'm Mark Brash, your host, and beside me is, yes, the completed and working Havit-Shop Model A602 3D printer. Finally. So, what did it take to get to this point? Well, let me tell you. During the assembly phase, I ran into quite a number of problems. Some of them were related to inaccurate documentation. Most of them were related to absolutely zero quality control. Absolutely zero component testing, and consequently quite a bit of troubleshooting time in order to get this thing to work. I am very happy with the design. I am really unhappy with the quality control that went into putting the kit together and any type of testing that should have taken place prior to assembling the kit. Having said that, moving forward, now that I have it working, I would like to go through the bed leveling process that I employ with not only the A602 printer, but also the A600 printer that I assembled prior to this. The assembly and the leveling of the hotbed is exactly the same for both units. Note that I have taken the frame of the A602 printer and I have centered it on this piece, this very flat piece of Corian material that I used for the A600. In fact, I did swipe this from the A600 in order to remount it onto the same flat surface. It then sits on 3 rubber feet, one in the middle at the front and 2 at each corner in the rear, so that I can set it on any surface, be it level or not. And I always know that the printer is sitting on a perfectly flat surface so that it doesn't distort the calibration of the hotbed underneath the nozzle. In the previous video, I showed how I was using an optical limit switch on the Z-axis rail on the left-hand side. You'll see now, instead of doing that, what I did was I reprinted a Y-axis limit switch holder, put it on the Z-axis rail, and now I can adjust my nozzle height above the bed by moving the limit switch up and down, whereas it originally was fixed and you had to go about it bass-ackward, as I described in the previous video. One of the things that I ran into with both printers is that when you have a print in process, the vibration that's taking place of the hotbed moving back and forth tends to cause the screws that run through the center of the support springs at the 4 corners of the hotbed, they loosen up. So as they loosen up, the calibration changes and the bed gets closer and closer and closer to the tip. And as it's trying to deposit the plastic, the bed getting closer and closer, it's not anticipating that bed coming closer, and it's still extruding the same amount of plastic, so it ends up pooling up in front of the nozzle and creating all kinds of problems as it tries to print. So the first thing that I'm going to do is I'm going to take and put a little bit of one of my favorite adhesives, goop adhesive, underneath the heads of the 4 screws that I have going down through the corner of the hotbed, so that they will not rotate in the holes on the hotbed. And then once I have everything leveled the way I want to, I'm going to lock the nuts into place with a little dab of the same glue to just prevent them from vibrating loose. Very important. And it's something that nobody talks about. I don't understand how they not talk about that. I don't use wing nuts. I use just hex nuts on the bottom, and you can see that the springs are nice and centered around the screws that support the four corners of the hotbed, because I have the 3mm inside diameter washers centering the spring and keeping the ends of the spring square. Gary Langwell just showed me this evening a little cup design for the springs that he put together that would actually replace what I'm doing here, and kind of makes what I did look a little silly, quite frankly, but that's okay. That's okay. I did it the hard way. Gary, I'm encouraging Gary to post his little design to Thingiverse because it's kind of cool, and it might save you from having to glue the little washers on the end of the spring, because that's kind of a tricky process. So let's talk about how I go about leveling the bed. All right, I'm going to be adding this piece of glass to the surface of the hotbed, and if I did nothing else, I would at least have to compensate for the thickness of the glass that I'm adding to the hotbed. What I do is I start with a pre-measured distance between the hotbed and the aluminum plate below it that holds the hotbed. How do I do that? It's very simple. Pick any item that you would like. You could take a threaded rod like this. You could take a center punch like I'm about to use that has a 3/8 inch square body to the center punch. And I'm just going to take the center punch and slide it in between the gap on the bed, and I'm going to make all four corners the same distance. So I'm just going to push it down, slide the nut up, and there's very little play, and I'm going to do that to all four corners. Just set it like that, very loosely, tighten the nut. And the reason I start this way is because I know that the printer itself is sitting on a very flat surface. I know that the Y rails are parallel, and are parallel not only to each other, but also to the surface of the platform that the printer rests on. So it should be a reasonable assumption that if I were to take and level the bed, oops, what did I do here? Yeah, that's the way. So it's a reasonable assumption that if I level the hotbed to the plate that supports it, then it should be at least reasonably level underneath as it moves around underneath the nozzle. So the next thing I'm going to do is I'm going to take this 3D printer and I'm going to attach it to my computer, and I'm going to load up a program called Pronterface. Pronterface gives me a nice, easy user interface between the computer and the printer that allows me to A, manually control the print head, preheat the nozzle, perform homing operations, and load files onto the load files from the SD card, and initiate a print that is already stored on the SD card for the 3D printer. So first thing I do is I click the connect button. It gives me a series of messages, tells me that it's connecting, and it should tell me that the printer is online any moment now. Oh, it already did that. Okay. And now I can hit the home button on the graphical display, and the printer will home X, Y, and Z. Just like that. So let me now just briefly describe to you the order in which I proceed to get the bed leveled. I've already roughed the bed by placing a 3/8 inch shim at all four corners and pre-adjusting the corner screws to get an even height above the plate that slides on the y-axis. The first point that I want to get calibrated is I want to get the nozzle to sit right on top of the glass at the starting position on the plate over here at 0, 0, 0. All right. Once I get that position dialed in, and I do that by moving the Z limit switch until when I home it, it comes to a stop just above the glass. And by just above the glass, I mean not touching the glass, but still close enough that I can't pass this little piece of paper underneath the nozzle to get it past the nozzle underneath the glass. That's what I mean by getting it just above the glass. Once I have that position, I raise the nozzle 10 millimeters in pronterface. I move the nozzle across the x-axis all the way to the opposite corner. I drop it back down 10 millimeters, and it should travel level across the plate. If it doesn't, I make that next adjustment with the motors energized by taking the lead screw and forcing the lead screw slowly, step by step, until I get it at least very close at this corner of the printer. The reason I do that is so that I know that the X rails now run parallel to the plate as it sits, which is roughly very, very close to where it should be to begin with. That's how I proceed. Once I've got the nozzle very close to the position that I want by adjusting the lead screw and forcing the stepper motor out of sync each time I do that to get this corner leveled properly, then I make my final adjustments with the nuts on the bottom of the corners of the plate itself. Only then do I move the nuts at the corners of the plate. Likewise, I will raise the print head 10 millimeters, bring the y-axis all the way to the top right hand corner, drop the nozzle 10 millimeters again, make my final adjustment with the nut only at this time because I don't want to make any more corrections with the lead screw, and repeat the process for the X, the 0X position, Y100 or Y200 position on this corner of the hotbed. That's how I go about it. So it's limit switch first, lead screw next on the two front corners. After I get the lead screw, make my final adjustments with the nuts, and then make final adjustments with nuts to the two back corners. Okay, I'm going to perform the home sequence again. As you can see, I now have the glass secured in place with these paper clips, heavy-duty paper clips that clamp it to the four corners, two fronts and two rear. And I'm going to home the XYZ. Watch very carefully the level of the bed right now. Watch what happens when I home this printer. Did you notice the level of the printer move? Okay, that means that the home limit switch is too low on the Z rail. So I'm going to raise it up out of the way. It's secured pretty tightly, so I'm just going to wiggle it back and forth as I push up on it to move it a little bit. And this will not drift. Once it's in place, it really doesn't move because there's very little pressure that's exerted on the lever of the switch. So let's home the printer again and watch it very carefully to see if it moves. And I still did detect a very tiny bit of motion. I'll raise it up again. Now I want to make sure that the tip has no residual plastic on it because that will add to the thickness. And I'm just going to raise the nozzle up high enough so I can get access and look underneath to see how clean it is. And that looks pretty clean. So I did a good job cleaning it off the last time. So I'm just going to wiggle the Z axis up a little bit more and do the home homing operation, and keep doing that until I get just the right gap between the nozzle and the surface of the glass. All right, after about 15 minutes of tinkering with the Z-axis limit switch and rehoming the nozzle over the bed and just going in here with my piece of paper. Incidentally, this piece of Post-it note paper, if you measure it with a digital caliper, is 0.1 millimeters thick. So what I do is, after I get it where I want it, in Pronterface, I can lift the print head by 0.1 millimeter increments. So if I can't get the paper underneath the nozzle when it's perfectly homed, but I raise the print head 0.1 millimeter, now I can slide the piece of paper underneath the nozzle. That's it. I'm there. I've got it just where I want it. All right. And at this point, I'm not going to play any games. I'm going to go ahead and I'm going to put some goop adhesive on the nut down below here so that it won't come loose again on me. Just a little dab will do you right on the corner. And that will peel off later if you need to get it off to make other changes. Now I'm going to lift the head 10 millimeters. I'm going to push the head 200 millimeters over to this corner here, drop the head, and then make my adjustment and check my adjustment on that corner. So here we go. Now I'll drop the print head 10 millimeters and see if the table moves, just like before. And it did not move. Okay, in fact, as I look at it, I see that I've got quite a gap, probably one full stepper motor step down. So I'm going to grab the lead screw. I felt the click, okay? And now I can't get the piece of paper through. Let me raise it up 1/10 of a millimeter and see if I can get the paper through. And I can. Okay? Perfect. Now the way I have it set in the firmware, once it finds its home position, you cannot manually force it past the home position. The firmware that is supplied with the A602, while it is the same type of firmware, it is Marlin version 1.0.0 that comes supplied with the A602. I installed Marlin 1.0.2, which is the latest stable release from the GitHub repository. And in the firmware settings, I have it set such that you cannot allow the stepper motors to force it beyond the limits that is set for home. Unfortunately, Havit-Shop didn't have the foresight to enable that feature in the firmware, so it is possible after it's homed to manually force it beyond the home limit position and jam the axis, jam your switches, and force a whole recalibration all over again. So yeah, word to the wise, I'm going to make the Marlin firmware that I'm using in the A602 available with my modified configuration H file. It is uploaded with Arduino software into the controller so that you can use the features that I'm describing to you right now. So I have the Z-axis home now for both the front left and the front right corner of the bed. Raise it up 10 millimeters. Now I'm going to move the Y-axis. I'm going to drop it. And let's see how close I am. Okay, so the paper slides under here fairly easily. So I'm just going to loosen up the nut a little bit, raise the bed. Just enough so that I can't get this piece of paper to travel underneath the nozzle. And I'm already there. Okay, this is about 0.1 millimeters off. So I'll loosen it up just a little more. And I shouldn't be able to get it underneath, and I can't. Now I will raise it 0.1 millimeters in front face, and if I've done my job correctly, the paper slides right underneath. This corner is done. Get some goop adhesive on both of these corners that I just did. And last but not least, this back corner. So let's drop it as far as I can. Bring it up 10. Move the x-axis back over. Drop it down 10. I can't get the paper through. Move it up 0.1 and the paper goes through. So the premise that I gave you earlier, that by roughing it out with a gapped instrument in each corner first, is accurate. As long as you set this on a very flat surface and you preset your spring heights at all four corners first, and then go ahead and set your z-axis height with the limit switch on one corner, get the other corner set by adjusting the lead screw, and then repeating the leveling process for the two back corners with adjusting the nuts on the screws that raise and lower those corners. That is the leveling procedure. After you have the lead screws synchronized, as long as you don't mechanically disturb the printer in any way, in terms of trying to cause these to come out of sync, they should always remain in sync with one another. And they remain in sync with one another not only by the drive electronics that sends the signal to them to cause them to spin in synchronization with each other, but when you manually rotate the lead screw, the motor windings generate an electrical signal. If the opposite motor, which is connected in parallel, is loading across this, it will tend to fight. It will even try to move with it as you move the lead screw. If you rotate this lead screw fast enough, even without the electronics in place, if you take the two motor windings and you put them in parallel, the other lead screw will start to move with it. So just so you know, once you have these lead screws synchronized, they should stay synchronized unless something really bad happens, in which case it shouldn't be a big deal to get back to where you need to be. Just home the z-axis and get the other side leveled with the lead screw on a full step of the stepper motor, and you're done. Thank you all for watching. As always, please rate, share, comment, and subscribe to my videos. And peace, everyone. So first thing I do is I click the connect button. It gives me a series of messages, tells me that it's connecting, and any moment now. Oh, it already did that. Okay. So then I click the home button and it still does nothing. What did I forget? Outtake number 2. Take number 3. Okay, so in the last 2 previous takes that failed to move the print head when I tried to show you how to do this, I forgot to realize that I can plug the USB cord into the front of my computer, and as soon as I do so, you'll notice the LCD lights up, but the motors won't move if you don't plug the AC cord in.